That's what we're going to do next. Okay? Alright, so theoretical yield is where you start with the amount of limiting reactant. Listen please, I don't have a lot of time. You need all the time I've got. Okay? You start with the given amount or measured amount of limiting reactant. And you calculate to the product. Same math, mass to mass. Okay? Once you identify your limiting reactant, then you can calculate the theoretical yield using the same process. And your product is going to be this stuff right here because that's what you collected. You know it because that's the only solid you made. That makes sense? Okay?
Wait, what number did you start with?
The amount you measured out of your limiting reactant. Okay? So yesterday, didn't we do an example problem yesterday in class?
Yes.
Where we found the limiting reactant? Yeah, long period. Oh, we actually did this yesterday in class as an example, didn't we? Okay. I just got them out of order here. So yesterday, when we did this example, we found that we had 0.941 grams of sodium sulfate, but we had 2.25 grams of sodium sulfate in the problem. So this is less than that. This is the excess reactant, making the other reactant, in this case silver nitrate, the limiting reactant. So silver nitrate is a limiting reactant. And then, as an example, we turned around and calculated the theoretical yield. We started with the given amount of the silver nitrate from the problem. So in the problem, we said there were 2.25 grams of silver nitrate. We started with that given amount, the measured amount of silver nitrate, and did a mass-to-mass calculation. But now, instead of going to another reactant, we went to the product we were seeking. Here's the product on the top. So when you do your theoretical yield, you're going to have what on the top here? What's the species you're calculating to? Huh? Lead iodide. There you go. Okay.
What if the one you're seeking is all going to be a solid?
At this point in the semester, that's all the information that you have to be able to do. It doesn't necessarily always have to be, but that's what we're doing in here. Okay?
What exactly is the theoretical yield?
I'm glad you asked that question. Because the theoretical yield is the maximum possible amount of product that you can get, but you never get it. Okay? It's the maximum possible amount of product you can get, but you never can get there.
Why do you never get it?
Huh?
Why not?
Because that's the outer limits. It's kind of like absolute zero. You can't really get there. Okay?
You'd have to have 100%.
You have to have 100%, and you can't have 100% because it's always something that doesn't get collected. Okay? Or the reaction isn't absolutely complete. All right? Now, which brings us to the next calculation you have to do for tonight. You're supposed to have a theoretical yield. Now you have to calculate a percentage yield. Okay? Percent yield. Now, percent yield is really, really easy.
Really?
Yes. A percent yield is really, really easy because it's the actual yield. So that's the amount you measured out. You went back there just now in lab and you measured your product and you're going to subtract the weight of that watch glass and filter paper to give you the amount of your lead iodide you collected. Okay? That's your actual yield.
You already found the theoretical yield on there?
You should have as homework. Found the theoretical yield for your lab.
I did, but I got the first one wrong, so that's what I got. So
Then you need to go back and recalculate that. It's a mass-to-mass calculation like yesterday's example.
It's supposed to equal what we got back there?
No, it's not supposed to equal it.
Okay, good.
Actual yield should be less than the theoretical yield.
All right, good.
Okay? That's supposed to be that way. All right, so what you're going to do is you're going to take your actual yield and you're going to put it over that theoretical yield that you calculate. And because it's a percent, you're going to multiply by 100. And that's how you get a percentage yield.
So wait,
is when you measured your material back there, after you subtract the weight of the watch glass and the filter paper, that should be your actual yield.
So the weight of the product.
The weight of the yellow product, the lead iodide product. Okay? So that's a percent yield. Okay? And that should be super easy once you get the other calculations done. Make sense? I mean, that's just simple stuff. This is third grade stuff here, right? All right. Remember, leave your units and species on here and cancel them where they cancel. What you'll find is percents are unitless answers. Okay? If you cancel the units the way you're supposed to, what I've taught you to, from unit 1, you'll get a unitless answer. Okay? All right, then. Last calculation.
Would you ever not get a unitless answer?
Not for percents. Percents are always unitless. Last calculation is the amount of excess reactant remaining in solution. What?
You said that was your what?
The amount of excess reactant remaining in solution.
What word?
Huh?
You said it was the last?
This is the last calculation you have to do for this lab and for mass to mass stoichiometry.
And that's what you're about to tell us.
I'm about to tell you. Okay?
Mr. Tedder, when's our test going to be on units?
Sometime next week. Okay? All right. At least that's what I think right now. It might be earlier, but I don't think so. Okay, so the way you do this is you start with your limiting reactant. So your limiting reactant goes over 1. Okay? And you do a mass-to-mass calculation. Till you get the mass of the excess reactant. So again, it's mass to mass. Okay? Got that? Once you have this amount, this excess reactant mass, this is actually the amount of that excess reactant species used up in the reaction.
Can you move the paper?
The amount of excess reactant used up in the reaction. You simply subtract that from the amount you started with. Okay, so you have the excess reactant species that you measured in the lab. You subtract, I'm sorry, yep, that's right. You subtract the excess reactant that you calculated, and that gives you the excess reactant remaining in the solution.
I don't understand why there are 2 excess reactants.
This is a theoretical amount, like a theoretical yield. It's not real. It's the amount, well, it is real in the sense that when you ran the reaction, when your limiting reactants ran out, the reaction had to stop. You can't make any more products once your limiting reactant amount stops. Does that make sense? Okay? And so that leaves that whichever of these 2 is your excess reactant, there's some of that still in the solution. Okay? So what you have to do, what we're doing here is just calculating the amount that could still remain in the solution. That makes sense? Let's say we're making cookies. Okay? Making cookies. And I need 2 cups of flour.
Should we write this down?
Nah. And I need 2 cups of sugar. And I need 1 stick of butter. Okay, and let's say 2 cups milk. I don't know how to make cookies. That's just what I'm going to say. Okay? All right? Suppose I've only got 1 cup of sugar. Can I still make cookies?
Lower the ratio.
Sure.
I cut everything in half, right? The cups of sugar are the limiting reactant. I can't make any more cookies than the sugar I have to make those cookies. Does that make sense?
Will you
Need
give an example
eggs.
of the theoretical yield?
Huh?
Will you give another example of the theoretical yield?
Actually, you have an example in your hands there for you to practice with. The sheet I gave you on your desk is the work you're going to do for the remainder of the period.
Wait.
But I did the example yesterday, but I still don't
Should take
understand
like
that.
Okay. There are, all right, listen please. In your unit handout, there are, right at the very end, there are about 5 different practice problems that are actually worked out for you at the end of your unit handout. It goes through it step by step. Okay? So you can work with somebody else in here that understands, and apparently a lot of people do. Okay? You can figure it out. You can use your unit handout. Okay? And just, it's just all, most of it's mass-to-mass calculations. Okay? Nothing more than what we practice. Okay? You just have to use the right mass-to-mass calculation for the right problem. Okay?